Is Vesta the smallest terrestrial planet? Presented by Science at NASA. NASA's Dawn spacecraft spent the last 4 years voyaging to the asteroid Vesta and may have found a planet. Vesta was discovered over 200 years ago, but until Dawn has been seen only as an indistinct blur and considered little more than a large rocky body. Now the spacecraft's instruments are revealing the true complexity of this ancient world. We're seeing enormous mountains, valleys, hills, cliffs, troughs, ridges, craters of all sizes and planes, says Chris Russell, Dawn principal investigator from UCLA. Vesta is not a simple ball of rock. This is a world with a rich geochemical history. It has quite a story to tell. In fact, the asteroid is so complex that Russell and members of his team are calling it the smallest terrestrial planet. Vesta has an iron core, notes Russell, and its surface features indicate that the asteroid is differentiated, like the terrestrial planets Earth, Mercury, Mars, and Venus. Differentiation is what happens when the interior of an active planet gets hot enough to melt, separating its materials into layers. The light material floats to the top, and the heavy elements, such as iron and nickel, sink to the center of the planet. Researchers believe this process also happened to Vesta. The story begins about 4.57 billion years ago, when the planets of the solar system started forming from the primordial solar nebula. As Jupiter gathered itself together, its powerful gravity stirred up the material in the asteroid belt so objects there could no longer coalesce. Vesta was in the process of growing into a full-fledged planet when Jupiter interrupted the process. Although Vesta's growth was stunted, it is still differentiated like a true planet. We believe that the solar system received an extra slug of radioactive aluminum and iron from a nearby supernova explosion at the time when Vesta was forming, explains Russell. These materials decay and give off heat. As the asteroid was gathering material up into a ball of rock, it was also trapping the heat inside itself. As Vesta's core melted, lighter material rose to the surface, forming volcanoes, mountains, and lava flows. We think Vesta had volcanoes and flowing lava at one time, although we've not yet found any ancient volcanoes there, says Russell. We're still looking. Vesta's plains seem similar to Hawaii's surface, which is basaltic lava solidified after flowing onto the surface. Vesta has so much in common with the terrestrial planets. Should it be formally reclassified from asteroid to dwarf planet? That's up to the International Astronomical Union, but at least on the inside, Vesta has characteristics similar to the terrestrial planets. If anyone asks Russell, he knows how he would vote. For more news about alien worlds, big and small, visit science.nasa.gov.
New app helps NASA keep track of meteoroids by Science at NASA. Surprising but true, every day on average, more than 40 tons of meteoroids strike our planet. Most are tiny specks of comet dust that disintegrate harmlessly high up in the Earth's atmosphere, producing a slow drizzle of meteors in the night sky. Bigger chunks of asteroid and comet debris yield dozens of nightly fireballs around the globe. Some are large enough to pepper the ground with actual meteorites. With so much stuff zeroing in on our planet, NASA could use some help keeping track of it all. Enter the Meteor Counter, a new iPhone app designed to harness the power of citizen scientists to keep track of meteoroids. Using our app, people from all walks of life can contribute to authentic NASA research, says Bill Cook of NASA's Meteoroid Environment Office, which sponsored the project. The data will help us discover new meteor showers, pinpoint comet debris streams, and map the distribution of meteoroids around Earth's orbit. Whenever you go outside for a bit of stargazing, take your iPhone, iPad, or iPod Touch with you, advises Cook. Start the Meteor Counter, lie down in a safe, dark place, and be alert for shooting stars. The Meteor Counter operates using an intuitive piano key interface. Every time you see a meteor, simply tap the key corresponding to its brightness. Keys on the left correspond to dim meteors, barely visible to the naked eye. Keys on the right denote jaw-dropping fireballs, the kind you never forget. With each key tap, the Meteor Counter records critical data such as the time you saw the meteor, the meteor's magnitude, and your location. You can even turn on an optional voice recorder to capture your own description of events. Experts could comment on the trajectory and radiant of the meteor, while novices might prefer to simply shout out, "Wow!" Afterward, these data are automatically uploaded to NASA researchers for analysis. The meteor counter is designed for all kinds of observers, ranging from experts with experience in science-grade meteor observations to first-time skywatchers who might never have seen a meteor before. The beauty of our app is that it gradually transforms novices into experts, says Cook. As an observer gains experience, we weight their data accordingly in our analyses. The meteor counter also acts as a meteor shower alert. When a known shower is in the offing, the app pops up a reminder for observers. The news feed and events calendar is routinely updated by professional scientists to keep users informed of the latest meteor happenings. Cook encourages citizen scientists everywhere to try it out. The app is available free of charge in Apple's App Store, he says. Just search for Meteor Counter and let the observing begin. For more information about citizen science and how you can get involved in authentic research, please visit science.nasa.gov.
Rethinking an Alien World, presented by Science at NASA. 40 light-years from Earth, a rocky world named 55 Cancri E circles perilously close to a stellar inferno. Completing one orbit in only 18 hours, the alien planet is 26 times closer to its parent star than Mercury is to the Sun. If Earth were in the same position, the soil beneath our feet would heat up to about 3,200 degrees Fahrenheit. Researchers have long thought that 55 Cancri E must be a wasteland of parched rock. Now they're thinking again. New observations by NASA's Spitzer Space Telescope suggest that 55 Cancri E may be wetter and weirder than anyone imagined. Spitzer recently measured the extraordinarily small amount of light 55 Cancri E blocks when it crosses in front of its star. These transits occur every 18 hours, giving researchers repeated opportunities to gather the data they need to estimate the width, volume, and density of the planet. According to the new observations, 55 Cancri E has a mass 7.8 times and a radius just over twice that of Earth. Those properties place 55 Cancri E in the super-Earth class of exoplanets, a few dozen of which have been found. Only a handful of known super-Earths, however, cross the face of their stars as viewed from our vantage point in the cosmos, so 55 Cancri E is better understood than most. When 55 Cancri E was discovered in 2004, initial estimates of its size and mass were consistent with a dense planet of solid rock. Spitzer data suggests otherwise. About a fifth of the planet's mass must be made of light elements and compounds, including water. Given the intense heat and high pressure these materials likely experience, researchers think the compounds likely exist in a supercritical fluid state. A supercritical fluid is a high-pressure, high-temperature state of matter best described as a liquid-like gas and a marvelous solvent. Water becomes supercritical in some steam turbines, and it tends to dissolve the tips of the turbine blades. Supercritical carbon dioxide is used to remove caffeine from coffee beans, and sometimes to dry clean clothes. Liquid-fueled rocket propellant is also supercritical when it emerges from the tail of a spaceship. On 55 Cancri E, this stuff may be literally oozing, or is it steaming, out of the rocks. With supercritical solvents rising from the planet's surface, a star of terrifying proportions filling much of the daytime sky, and whole years rushing by in a matter of hours, 55 Cancri E teaches a valuable lesson. Just because a planet is similar in size to Earth does not mean the planet is like Earth. It's something to rethink about. For more weird news about alien worlds, visit science.nasa.gov. Some comets like it hot, presented by Science at NASA. Comets are icy and fragile. They spend most of their time orbiting through the dark outskirts of the solar system, safe from the withering depredations of intense sunlight. Their natural habitat is the deepest cold. Last November, amateur astronomer Terry Lovejoy discovered a different kind of comet. The icy fuzzball he spotted in the sky over his backyard observatory in Australia was heading almost directly for the Sun. On December 16th, less than 3 weeks after he found it, Comet Lovejoy would swoop through the Sun's atmosphere only 120,000 kilometers above the stellar surface. Astronomers would soon realize a startling fact. Comet Lovejoy likes it hot. Terry found a sun grazer, says Carl Badams of the Naval Research Lab in Washington, D.C. It appeared to be as wide as 2 football fields, the biggest such comet in nearly 40 years. Sun-grazing comets aren't a new thing. In fact, the Orbiting Solar and Heliospheric Observatory, SOHO, watches one fall toward the Sun and evaporate every few days. These frequent kamikaze comets are thought to be splinters of a giant comet that broke apart hundreds of years ago. Typically, they measure about 10 meters across, small, fragile, and easily vaporized by solar heat. Based on its orbit, Comet Lovejoy was surely a member of the same family, except it was 200 meters wide instead of the usual 10. Astronomers were eager to see the whopper disintegrate. There was little doubt that it would be destroyed. When December 16th came, however, Comet Lovejoy shocked us all, says Badams. It survived, and even flourished. Images from NASA's Solar Dynamics Observatory showed the comet vaporizing furiously as it entered the Sun's atmosphere, apparently on the verge of obliteration. Yet Comet Lovejoy was still intact when it emerged on the other side. The comet had lost its tail during the fiery transit, a temporary setback. Within hours, the tail grew back, bigger and brighter than before. It's fair to say we were dumbfounded, says Matthew Knight of the Lowell Observatory and the Johns Hopkins Applied Physics Lab. Comet Lovejoy must have been much bigger and tougher than we thought. Only a few days after it left the Sun, the comet showed up in the morning skies of the southern hemisphere. Observers in Australia, South America, and New Zealand likened it to a searchlight beaming up from the east before dawn. The tail lined up parallel to the Milky Way, and for a few days made it seem that we lived in a double-decker galaxy. Astronauts on the International Space Station also witnessed the comet. ISS Commander Dan Burbeck, who has seen his share of wonders, even once flying directly through the northern lights on board the space shuttle, declared Comet Lovejoy the most amazing thing I have ever seen in space. An armada of spacecraft including SOHO, the Solar Dynamics Observatory, SDO, NASA's twin Solar Terrestrial Relations Observatory probes, STEREO, Japan's Hinode spacecraft, and Europe's Proba 2 microsatellite recorded the historic event. We've collected a mountain of data, says Knight, but there are some things we're still having trouble explaining. For instance, what made Lovejoy's tail wiggle so wildly when it entered the solar corona? Perhaps it was in the grip of the Sun's powerful magnetic field. What caused Lovejoy to lose its tail inside the Sun's atmosphere, and then regain it later? This is one of the biggest mysteries to me, says Badams. And then there is the ultimate existential puzzle. How did Comet Lovejoy survive at all? The comet that liked it hot is returning to the outer solar system, apparently still intact, leaving many mysteries behind. It'll be back in about 600 years, says Knight. Maybe we will have figured them out by then. To learn more about solar system mysteries, hot and cold, visit science.nasa.gov.